DHCP. At the same time, one of the most useful of the services, and probably also one of the least exciting. I don't think DHCP ever got anyone bought free beer. I don't think DHCP is one of those services that launched your career. DHCP is one of those things that when it doesn't work, people are really upset, and when it does work, nobody really cares. Now, we are in this exam and for this series talking just about the advanced features with all these things we're talking about. And that is no different here in this nugget. We are going to talk about when you go about implementing DHCP, well, what are the potential advanced pieces of that that you'd want to pay attention to? So I'm going to assume that you've already created a DHCP server, just like next with the DNS server. You've already put this together because you had Active Directory. I'm going to assume that you probably got a scope up and running. But there are a couple of things here that are in some cases edge cases, and some cases actually really useful, especially down here, that you just kind of got to know in order to be successful with DHCP. So what are they? When you're creating DHCP scopes, there are some additional scope types that you can make available for specific uses. The multicast scope type is one that gets used whenever you're doing any kind of multicast type traffic. Now, what is multicast traffic? The biggest example, at least in the Windows world these days, is going to be WDS. So I need to use multicast to distribute out Windows images with WDS. I can either just have the clients assign themselves a multicast address, or I can provision them through a DHCP server. That's really what the options are. Back in the days of Ghost used multicast as well. There are other services out there that use it, but they're kind of edge cases these days. These superscopes are items that you may actually find yourself using. And as your environment size gets a little bigger, you might find yourself using, because superscopes are literally the ability to merge multiple scopes together. So let's assume that you have a scope 192.168.2.0 and 192.168.3.0. Well, in the 2.0 network space, you have potential addresses between 192.168.2.1 and 2.254. You're probably not going to use all of these, but that's how wide the scope could potentially be for this Class C subnet right here. Now, if I'm using 24-bit subnet masks, a lot of us do, then it's nice because 24-bit subnet masks means that these first three numbers in the IP address are going to be my network mask. But that also means that I only get 254 addresses before that subnet starts to run out of IPs. So if I got an environment where I've got more than 254 machines that may be connecting up to DHCP, well, I got to figure out some way of managing these multiple different potential scopes. These superscopes is literally the ability to take two scopes and merge them into a single scope. The idea being that your primary scope will hand out addresses until it runs out. Right? I get to my 254 addresses and I'm done. And then once that's done, it rolls over to the next scope in the superscope. Useful here if you end up having that nice but also limiting 24-bit subnet mask, 255.255.255.0. You do have to be conscious, however, when you're creating superscopes, because the server, the DHCP server itself, typically has a single network address that it is connected up into. I mean, our DHCP server here is 192.168.1. I think it is 200. And so out of the box, by default, without any extra crazy networking configuration, the only addresses that DHCP server is actually going to be able to even see or talk to or provision are those that are going to be on this 192.168.1 subnet. Again, I'm assuming here a 24-bit subnet mask. So I'll show you how to implement superscopes, but with the little asterisk, the little caveat that there's some additional networking food that needs to happen in your Cisco world or in your networking world in order to ensure that your DHCP server can actually see these additional subnets. That can happen perhaps through VLANs. That can happen through some Cisco magic. That can happen with multiple network cards. But all of these are kind of out of scope for what you need to know here for this exam. So you'll need to work with your network team to ensure that whatever server can support actually seeing these addresses if you plan on making use of superscopes. Now, interestingly enough, we will talk about how to implement these, and we'll talk also about how to implement DHCP version 6 as well. But interestingly enough, DHCP version 6 is kind of a curious little service because DHCP v6 is perhaps not the simplest way to assign addresses. If you played around with IPv6, one of the neat things about IPv6 is that clients can automatically assign themselves stateless addresses. So if you take an IPv6 client, you plug it into a network, it's going to be able to give itself an address if it needs to. But some environments get to the situation where they want to be able to manage the exact addresses that each client actually has. So rather than having clients just giving themselves any address in that very wide range of DHCP or of IPv6 self-assigned addresses that exist out there, some environments may want to actually use DHCP and DHCP's database as a mechanism to see, well, who's got what address. So you implement DHCP v6 not so much because you absolutely need it for auto assignment of addresses. You do it because you want to manage the list of addresses. Now, a couple of interesting caveats here too is that with DHCP v6, you can assign an address. You can get an IP out to a user, yay, but you cannot actually use DHCP v6 to assign a gateway, a default router to a machine. In order to accomplish that, you have to have some other mechanism outside of DHCP v6 in order for those machines to get their default route. That typically happens again at the network layer. Your routers advertise their default route and the client obtains it from there. Where you can actually use DHCP v6 is in assigning options that are other than the default route. So maybe like a DNS server, for example. You want to assign a DNS server, or you want to assign a NetBIOS name server, or any of the multitude of possible additional services that are associated with networking. So you implement DHCP v6 primarily because I want to be able to see who's got what, and then to manage these additional types of scope options that are out there. But recognize again that there is that limitation because, well, you're not going to be able to get gateways. And so with DHCP v6 alone, your machines will not be routable. These days, most of this happens at the network side anyway, so you know what? This is something that you'll implement in combination or in cooperation with your network teams. We will in this talk also talk about some of the HA options, high availability options for DHCP, of which there are now two, DHCP failover and split scopes. So back in the old days, the split scopes option was the way in which we would have more than one DHCP server online. And split scopes are very simple in that you literally have two different DHCP servers with two different databases. So here's my server and here's the database that it's connecting up to. And a split scope literally splits the scope so that some portion of the addresses go on one server and some portion of the addresses go on the other server. So back to our example here between 1 and 254. Let's assume that I want to split the scope in a 50-50 situation. So I'll put from 1 to, what is half of 250? 125 plus 1, 120, I don't know. Here, let's do 127, easy number. So from 1 to 127 on one scope, and then from 128 to 254 on the second scope. This is a 50-50 split. In the old days, more commonly, you would see not a 50-50 split, but in fact an 80-20 split. So 80% of the addresses on the primary server, 20% of the addresses on the secondary server. You might be asking yourself, well, why would I do an 80-20 split if I have this range of addresses? Wouldn't it make sense to actually load balance these addresses between these two hosts? Well, it does. However, in the split scopes world, when I'm literally just taking the address range and handing out some to one server and handing out some to another server. One of the limitations here is the fact that these servers have no idea which addresses the other server has handed out. So when I end up in that situation where one of the servers has died, the other server, it has no idea what's already been released. And so we tend to do it in an 80-20 world, because if I happen to lose my 80% server over here, well, then the 20% server is not so much there for absorbing all the need for DHCP services for an extended period of time, but the 20% is there just so that it can support any DHCP requests for the short period of time it takes to get my main server back online. So less so for a failover, there for just temporary DHCP services should that primary server go offline. Now, over the years, people have kind of said, this is kind of dumb. And wouldn't it be nice if we had some sort of clustering solution, that's a loaded word, but some sort of solution that allows these two servers to actually know what's going on between the two servers? Well, thankfully in Server 2012, we implemented a new technology called DHCP failover, which is a much better solution for managing scopes, because the primary difference here is exactly this, that there is one scope. It's balanced between two servers, and when the scope fails over to the secondary server, well then the secondary server has the complete database and a complete understanding of which addresses have been handed out. This is awesome, and in fact, if you can implement DHCP failover, it's probably the better solution for the two. We are in this nugget also going to talk about a couple of little minor things as well. We will talk about how to make sure that you register DNS. You register addresses with DNS, so your DHCP server becomes a proxy, more or less, in some cases, for registering DNS addresses as they're handed out. There's also the need for name protection in the case where I have non-Windows clients that may be attempting to register through DHCP and also through DNS. And then I want to show you a couple little things like filters and policies and just some other kind of advanced topics not listed here, but that can be useful as you implement your advanced DHCP servers. So let's talk about each of these tasks in turn: superscopes, multicast scopes, DHCP v6. I'm here on DNDC1, and I'm going to go here to DHCP, and I will show you the crazy exciting console here of DHCP. You've seen this already because you've played with scopes before. And here I have a scope set up, 192.168.1, 100 through 150. If I'm creating a superscope, typically the superscope is something that's created between scopes of different subnets. So let's say I were to create a new scope here of 192.168 2.100 through 2.150. This is just a label here. And I'll start it for 192.168 2.100 and 192.168 2.150. If I choose the next button here, and I'm going to avoid the exclusions, keep the same least duration. I'm not going to worry about DHCP options, but you could configure those like DNS servers and Win servers and BootP servers or what have you. I'll choose next here and finish to create this secondary scope. When it comes time to actually create my super scope, and activate that scope there. When it comes time to create my super scope, literally all I'm doing is taking a couple of addresses, so 192.168.1 and 192.168.2. Well, come up with a better naming whenever you do yours. Choose next here, identify the scopes that I want to add to the super scope, and I'm done. That's literally all that you have to do with super scopes. Remember though, that anytime I'm implementing superscopes, there's more work that's required at the network layer. The Cisco people, the network team, has to make sure that those scopes are available and visible so that the DHCP server actually knows what addresses it's handing out. I do want to show you multicast scopes too. And first I'll show you what a multicast scope looks like here in the wizard. Then I'll explain more about where you might potentially use one. I'll show you one good example. So you may be aware that multicast addresses are the ones at kind of the top end of the IPv4 stack. So I think they're above 224.0.0.0. Multicast are reserved addresses, and the whole point behind multicast, if you're not already aware, the whole point behind multicast is so that one server can send out essentially one stream of packets that gets received at the exact same time by multiple machines at once. This is important whenever I have the delivery of a lot of content that is exactly the same for a bunch of different machines. Ghost is a perfect example. Windows deployment services are perfect examples because using multicast, I can send out one copy of the operating system I'm attempting to deploy, and each machine receives it and then processes it all at once. Now, one of the interesting things about multicast is that in almost all the environments I think I've ever been involved with, multicast has been something that has been absolutely verboten, forbidden, shut down, and prevented by the network teams. And one of the reasons for that is that multicast happens to be fairly notorious in flooding a network anytime you have a major multicast stream going on. And so you can imagine, if I got this WDS server that's sending out this operating system and multicast is exposed everywhere on the network, well, that can have the potential of really flooding the switches with traffic and reducing the overall performance. So even though you can create multicast addresses in virtually every environment I've ever worked with, multicast is shut down so that it cannot pass a subnet boundary. You can do it inside a subnet, but it'll never pass through a router. When I create a multicast scope, I got to give it a name, so let's call it 224.0.0.0 through, I don't know, 224.0.0.100. I'll choose next. I'll identify what the scope range is, just like a regular address, 224.0.0.0 through 224.0.0.100. This is the time to live, or essentially how far can this multicast traffic go before it's shut down. You think about it, if I've got routers all around my network, this thing hopping through 32 different possible routers could mean that I could flood an entire huge network if I wanted with a single operating system deployment. So again, there's a reason why this stuff tends to get shut down at the router boundary. Next again, any exclusions there, the least duration. Do you want to activate the multicast scope? Yes, and then we're finished. So there's a multicast scope. Now that is not really terrifically exciting until you really kind of understand why you might implement these. And it's, I guess I'll say it's not so much why you would implement them, but maybe where you would implement them. I've got a WDS server here on my network that, if I can actually punch in the right password, that I will connect you up to so I can show you where the option for configuring DHCP resolution of multicast addresses can actually happen. So here's my little WDS server, and if I bring up Windows Deployment Services console, I'll show you where you could make this change. In most production environments, you're probably not going to see this implemented. Again, I don't think I've actually seen an environment where multicast was extended beyond a subnet boundary. I don't think I actually have. But if you wanted to, here under Properties and the Multicast tab in WDS is where you can define where you're actually going to pick your multicast IP address. Now, I've been using WDS for a long time, and I've had it set here for using addresses from this range, so self-identifying addresses in that range, and I've had reasonable success with it for a really long period of time. However, if I wanted to use DHCP, well then simply I choose this top box here for my network card to request that multicast address from an available DHCP server. So you can choose which option you want. If you have more than just a few clients that are doing WDS at the same time, you probably might want to do this one because your clients may end up conflicting with each other if they're all trying to self-select whatever address is available in that 239net subnet. So that's where you would go about actually configuring one element of multicast so that it would use your DHCP server instead of self-selecting. So this is Superscopes, this is multicast scopes. I want to show you a couple of other kind of just little advanced things here inside of the DHCP console that you might have missed the first time through. First one here are filters. Just be aware too that these filters allow me to either filter in or filter out specific MAC addresses. So if I know I have some MAC addresses that I want to ensure do not ever get a DHCP address, well, I can drop them here in my deny list. as a new MAC address with a description to say, you know what, that MAC address will not receive DHCP services. Conversely, over here, I have an allow filter, which can do the same thing. This MAC address will receive DHCP services if I want to turn this on. I can also set some policies here as well. These new policies are defined to give you just a little tiny bit more of granular control over the incoming clients, the requesting clients that need an address, and what kinds of configurations you might give them. So if we create just a test policy here, where this thing gets used is based off of a series of conditions that you may configure here. And you don't see this get implemented too often, because more often than not, it's the network location of the client that determines what kinds of network addressing it needs, or network options that it needs, more so than any configuration of the client. But you can go through and by vendor, by user class, by MAC address if you want, by fully qualified domain name. You can go through these relatively minor categories to create a policy that lets you then determine which scope options you're going to associate to that particular device. So if I choose, I don't know, a vendor class equal to some option here, a Windows 2000 option, okay, and you'll have to go identify what those are because they can be different for the vendor. If I set those in here, throw in a prefix wildcard, I just want to kind of show you what you get is you get the ability to configure, as you can see here, the DHCP scope options that should be associated to that device. So if I've got a particular device, I want it to have a different time server, or if I want it to have a different log server, all these old school ancient DHCP options, you can accomplish that here. You know, fantastic test question. How often do you see this in reality? Not that often. You know, every so often you will see. If you recall back that we created our multiple forest environment, one option you may actually see is here, not under vendor class, but fully qualified domain name. So, for example, if I have machines that are coming in that are advertising themselves as something.specialized.net, well, then I can provide them with different scope options if I want. Maybe point them to a different, I don't know, maybe point them to a different default gateway or a different route. All the options are there for you. Recall again, many of these technologies were implemented during a time that these were the only ways of doing these sorts of network controls. And so they're here, but a lot of them are here kind of as artifacts of a time long past. So policies and filters, fantastic advanced little things that you can add in here with your IPv4 scopes. IPv6 scopes down here, not a lot of options as you can see, again, because IPv6 mainly here so that you can collect and understand what the association is between addresses and names. Creating an IPv scope is pretty much similar to creating an IPv4 scope. You just have to put things in, obviously, in IPv6 notation. So if we wanted to create an IPv4 scope, we do, I don't know, FF02 would be the scope prefix. I can set here as my IPv6 prefix is FF02::, and then identify what the preference should be. This preference value, if you have multiple DHCP servers, the server with the higher preference value will be the server that your DHCP v6 clients are going to point to first. That's all you need to know here with the preference value. Choosing next, and the typical exclusions there, what the lease time is, and there's your new IPv6 scope. Now really the most interesting part here of DHCP is not so much the scopes themselves, but is more the high availability options that you can lay into place. I told you that there were two. There is the split scope approach, and there is the DHCP failover approach. And I want to just kind of point them out because the mechanism to implement these is kind of cool, honestly. We'll start with split scopes. Here, if I go to a server, I can configure for this scope that I've created, the super scope. I can create the ability to split the scope. And I cannot because I have put this in the superscope. Let's remove it from the superscope here and configure the split scope there. To set up a split scope, I obviously need to have two different DHCP servers. And I actually have one. The DEN-DC2 is the second DHCP server here, DEN-DC2. I'll add it. That is the server I want to add. It's down here, DC2 to the console. Choose next. And then here is the lovely little percentage of split option. I love this little drag box that I can drag it back and forth. Do I want to do 80-20? Do I want to do 50-50? How do I want to split the scope, the addresses in this scope? 80% over here, 20% over here, and what exactly will be the start and end addresses associated with that percentage split? When I'm done, I choose next. There is my delay between the primary scope and the secondary scope. Remember, I told you that the reason we do split scopes is not for load balancing. It's for failover for short-term outages. So in ensuring that I set the host DHCP server with a higher, or excuse me, with the added DHCP server with a higher delay in the DHCP offer ensures that that second DHCP server only starts answering queries whenever the primary server is offline. Okay, so I want to make sure that we put in a delay over here to the second one so that that second one is only being used whenever I'm overloaded or not functioning at all. Choose next over here and finished to create that split scope configuration. Now that is the old way of doing things. And in fact, even prior to, I think, Server 2012, you kind of had to set these things up almost manually. What we really would prefer to have is not so much a split scope configuration, but is instead the ability to literally fail over that scope from one server to the other. I'd like the secondary server to be aware of the addresses that the first server has actually released so that I can support having that second server be my DHCP server for perhaps something more than a very short outage, maybe an extended outage. When that happens, we need to turn on failover. And failover, you can think of it kind of like Windows clustering, like a service that is sitting on top of Windows failover clustering. Except the good part is that in order to use it, you don't have to implement a Windows failover cluster. All the extra infrastructure that's necessary to get that Windows failover cluster up and operational. So if I want to implement DHCP failover, I can configure the scope that I want, identify what the partner server will be, which again will be DEN-DC2, create the relationship name here. What's the client lead time? Am I load balancing or doing hot standby here? The hot standby, as you can see, only does 5% for the role of the partner server. The load balance here does 50-50 for the different scopes, but I could adjust it if I wanted to. Do I want to protect myself against the scope failing back too quickly? Anytime you're dealing with a clustered service, you got to worry about the failover happening and then failover and back and forth as the result of some intermittent problem. And so I can set up the switchover interval to be something less than immediate or something more than immediate. This will protect me from just those two servers bouncing back and forth, thinking each one's the primary because of some short-term problem. So I want to have them authenticate to each other. And then what's the shared secret going to be between those two servers? I'll punch in some shared secret. The shared secret is what's used to create that failover relationship. Choose Finish, and we have a successful configuration of failover. Once it's configured, there's really not that much to see here. I can take a look at the scope here and view the properties, see the failover tab, and see that, yep, we are in load balance. The state is normal. The state of the partner server here is normal. If I want to fail it over, I just power off the machine or shut down DHCP services to see this thing fail over and fail back. And you may be saying, you know, I wish there was just more instrumentation here. But in comparison with trying to set this thing on top of Windows failover clustering and all the bells and whistles and knobs and buttons you have to turn over in failover clustering, this is awesome because with something as simple as DHCP services, I just want failover to function, and I don't really want intricate control over it. It's a fairly simple service. And so greatly simplifying these makes things far more easy for us when we have to manage it over a period of time. While I am here, I'm going to show you two additional pieces that are also objectives for the exam. And they're properties that we can see here on the Properties tab of any of the scopes that we create. The first one here is just recognizing that there are a variety of options for having a DHCP server manage the registration of DNS records on behalf of the client. So here you can see we're enabling DNS, this is right out of the box, DNS dynamic updates if requested by the DHCP client. So if the DHCP client is requesting a dynamic DNS update, which is one of those settings whenever you're, do you want to request your DNS server on behalf of your DHCP server, whenever you configure the client, the DHCP server will do that for you. Do you want to discard the records when the lease is gone? Generally a good idea to help you scavenge that database. Do you want to dynamically update records for clients that do not request updates? So if you've got a really old client, like those running Windows NT4, I hope you don't have too many of those still laying around. And then also, do you want to, in rare cases, do you want to disable dynamic updates for DNS PTR records, reverse records? You don't find this happening all too often because in order for certain aspects of group policy to work, DNS has to have both a forward and a reverse record for each of the clients that are out there. I think it's specifically the site GPOs need to have that so you can identify what site you're in. So these are the options that are there. I would know what these are. The other one I want to show you is right here, DHCP name protection. Now, occasionally you may end up with a situation where your DHCP server is registering names for clients. But in some cases, you may already have a registration for that client existing in DNS. This could happen when you have non-Windows machines that are updating their DHCP records. You can have this happen when machines that aren't going through DHCP are updating their DNS records. And so because of that, because DHCP does not have single control over that DNS database, you may end up with some situations where DHCP needs to register a name. Well, name protection helps you in these situations because it ensures that the DHCP registration doesn't overwrite the existing one in DNS. This name protection can help you to ensure that a client that has not gone through DHCP is not going to end up getting its DNS record overwritten. Very useful selection here. Nice one to have in place so that your DNS and your DHCP aren't overwriting each other. So again, DHCP, wonderful solution, one of the most useful solutions that's out there in the world, but at the same time, perhaps not one of the most exciting solutions that is out there. What have we talked about this nugget? We've talked about some of those advanced things that make up a DHCP solution. We talked about how you might and when you might incorporate superscopes, and the rare chance that you might actually implement a multicast scope. We talked about DHCP v6 and how you can use it, but there is that limitation with setting your default gateway. There's a little bit of extra effort that's required at the router side, at the network side, in order to accomplish those if you're in a IPv6 network. Talked about some of those really cool high availability options like failover and like split scopes that now exist in DHCP. And then a couple of the minor configurations like name protection, DNS registration, filters, and policies, all of which are useful so that you can ensure the right clients end up with the right configuration. Coming up next, we're going to talk about the other half of network registration, and that is network resolution, DNS. DNS these days is the mechanism that clients use to find each other and to find network services. And while you have a DNS server already in place, because we have an Active Directory in place, there are some advanced DNS settings that we have to take a look at, and some of them are actually kind of cool. That is the topic for our next nugget, so until then, I hope this has been informative for you, and I'd like to thank you for viewing.